All right, 5.4 video notes, mid-segments of triangles. So the first three sections were all trying to find the different centers of triangles. We had circumcenters, incenters, orthocenters, centroids. So we were trying to figure out where a different center was for the triangle, depending on, did you want to be equal distance from the vertices? Did you want to be equal distance from the walls? Did you want to be the center of gravity? So now we're doing another special segment, but it's not finding the center. It's called midsegments. So the objective here is use properties of triangle midsegments, and let's define what a midsegment is. It is, let's use blue here. I said blue. It is a segment that joins two midpoints of the sides in a triangle. So basically you come up with two midpoints and you connect them together and you have a mid-segment. So over here to the right, I'm going to just kind of draw my own triangle. Something like that. And I'm going to find the middle of a side, so let's just come down here on the right side, maybe right about there, looks like the middle, and I show it's the middle by marking it. So there's one midpoint. And then maybe I'm going to do it on the bottom side here. Maybe I find another midpoint. I'll mark this with 2 tick marks. And now when I connect those two midpoints, that right there, what I just created, is called a midsegment. Alright, so mid-segment. And I can do it different ways, so I could also come over onto the other side, the longest side here, and I could find another midpoint. And if I connect these together, I have another midsegment, and I have another midsegment. So there are 3 midsegments there. And now there's some special properties that you can kind of see. One thing that I want to kind of note is we're going to find out later on that you basically end up with 4 congruent triangles inside there. 4 congruent triangles. Now 3 of them are oriented the same way. You know, triangles number 1, triangle number 2, and triangle number 3. They're all positioned the exact same way. Triangle 4 is a little bit special. He's still congruent, but he is not oriented the same way. All right, he's rotated around just a little bit. So we'll get into that a little bit more here at the bottom. But let's scroll down and let's get into probably the most important part, and that's the midsegment theorem. So there is a triangle midsegment theorem, and here's what it says. It says the segment that connects the midpoints of the 2 sides of the triangle is parallel. It's parallel to the 3rd side and is half as long as that side. Half as long as that side. So let me just do a little sketch right in here. So I have some sort of a triangle, all right, and I find a couple midpoints right here and right here, and when I connect those together, that blue line is kind of special because the first thing from our theorem up above is, the first thing is that this blue line is parallel to the side that it's not connected to. That they're referring to this down here at the bottom as the 3rd side. So the midsegment is parallel to the 3rd side. Now that's going to hook me up pretty nice later on because I'm going to know that some angles are congruent to each other. And the second thing I need to know is that the midsegment is exactly half as long as the side. So for instance, if this bottom here was 10, then I know that the blue line is 5. It's exactly half of the other one. Now I'll also get some things about some angles. For instance, this angle and this angle are going to be congruent because they are corresponding angles. They're in the same position. Because remember, whenever you have 2 parallel lines and a transversal, basically what we have are these 2 angles. We have just kind of erased all of this outside stuff, get rid of all this, and then we ended up making some sort of a triangle, come out the other side. And the same thing happens here. We get these two are equal, or that angle is equal to that angle with 2 marks, because they're corresponding angles. So there's kind of this third bonus feature that I really am not going to put it as number 3, but from the parallel lines you get some corresponding angles that fall out of that. Alright, so let's do example 1. I'm going to blow this picture up just a little bit for myself, maybe. There we go. Now we're talking. Alright. So find the measure of JL. So I'm looking at my diagram here, and I'm going to just get rid of this 3 because it's kind of in my way. So I need to figure out how long JL is. Well, JL is this side right here. And if I want to know how long JL is, I need to find the midsegment that's parallel to him. So the midsegment parallel to JL would be PN. And since PN is 36, that should be half. So if I do 36 times 2, that comes out to be 72. So JL is 72. Now PM, if I need to find PM, well, PM is a midsegment. And if I want to know his size, I look across the triangle and I see the third side he's parallel to. This time I got to go backwards. I have to divide. So I'm going to do 97 divided by 2, which is going to come out to be a decimal. That's what, 48.5, I believe. You always got to double check my math because I'm usually not using a calculator and just kind of do a mental math. So always double check me and let me know if I make a mistake. The measure of angle MLK. So let's find MLK. M to L to K. So that would be this angle right here. And to get that angle right here, I can use this set of parallel lines to go up, and I find a corresponding angle. And that is 102. So this angle should match. It should also be 102. Alright, so quick little friendly example 1. Let's roll down and see if things get a little bit tougher. And example 2 on the bottom here, find each measure. Looks like a similar picture. The measure of ED, well, E to D is here, so if that's the midsegment, use the longer segment. It's 20, so we go backwards, chop it in half. You will get a number of 10. We want to find AB. So AB is this side of the triangle right there. And we look to his midsegment that he's parallel to, and it's 7, so that should be 14. I should be able to double it. And the measure of angle BFE, and B to F to E is this angle right here. That's angle BFE. And so I'm going to slide on down to this angle that corresponds, and I find out it's 44 degrees. So very similar to the top problem. Let's see if we can get into anything a little more difficult down here. I see some algebra, so this one might be a little bit rougher. So this time they don't give me all the midsegments. They just focus on one. And they don't tell me it's a midsegment, but because of these markings, I know that that's a midpoint, and because of these markings, I know that this is a midpoint. And the segment that connects the midpoints has to be a midsegment. So there's a few things I know. Number one, I know that he's parallel to him, although I don't see any angles that we need for this problem, so that's not going to come into play. But I do need to know that the midsegment is half the third side. So there's two ways to think about that. I could write that out and say the midsegment is half of the third side. But I'd rather not deal with fractions if I don't have to. So the same thing I could also say is, I could also say that 2 midpoint or midsegments equals the third side. All right? Two midsegments equal the third side. So the midsegment was n plus 14, so I'm going to do 2. If I double m plus 14, that should tell me what 3m plus 12 is, because 2 times the midsegment should be the third side. So now we do a little bit of algebra here. 2n plus 28 when I distribute. And I'm going to minus an n from, or 2 n's from both sides, and I get 28 equals n plus 12. And then when I subtract 12 from both sides, I find out that n is 16. Now I should probably plug that in, just make sure that it jives and it works out. So 16 plus 14, well that's 30. And 3 times 16 plus 12, well that's 48 plus 12, that's 60. And they do what they're supposed to do. The third side is twice as big as a midsegment, so it looks like it worked out pretty nice. Alright, number 4 over here. XYZ is the midsegment triangle. So all they're saying there is this little guy in the middle, they're giving him a name. They're calling him the midsegment triangle. Okay, because he's the triangle that's created by all the midsegments. They make him. So XYZ is a midsegment triangle of WUV. What is the perimeter of XYZ? So they want the perimeter of the smaller triangle. So let me get rid of this color here and let's try to get some numbers. Well, if this long side out here is 9, this side is 9, the midsegment should be half of that. So this midsegment should be 4.5. And I'm actually going to blow this up so that you guys can see that a little bit better. Let's just kind of blow you up a little bit. There we go. Now I got some room to work. So if this side's 9, the side parallel to it is half. That's 4.5. This side we have already. That's 3, which means this side over here is 6. And then over here, this 4 represents just this piece. So if that piece is 4, this piece is 4, which makes a total of 8 on this side, which half of 8 would be 4. And if you notice, if you keep going around, you know, if you split this 9 in half, you get 4.5 and 4.5. And now I have every single side, this 6 over here, split it up into 3 and 3. If you notice, every single one of these triangles are congruent to each other. I have 4 congruent triangles by, well, what property or theorem? Side, side, side. Every single one of them has side lengths of 3, 4, 4.5. So those 4 triangles are definitely all congruent with each other. Alright, we got one more example. It looks like example 5. It's got a couple 2 or 3 parts to it. So let's get after this one. If DE is 4x plus 5, 4x plus 5, and GJ, that's the big dog down here, the big dog is 3x plus 25, what is DE? Well, I'm going to use that fact again that I know that if I do 2 times the length of DE, that should come out to be the length of GJ. So I'm going to double the 4x plus 5, set that equal to the 3x plus 25, and a little distributive property action. Now some of you in your head maybe could have just started with this step right here. You might have just looked at that and said, hey, I can double that in my head, and kind of skip the first 2 lines. That's fine. I don't have a problem with that. Minus the 3x from both sides, I get 5x plus 10 equals 25. Minus 10 gives me a 5x equals 15. And divide, and I get x equals 3. Now, did I answer the question? Doesn't look like it because they said, what is DE? So take your 3, plug it in. 4 times 3 plus 5 is 12 plus 5. That would be 17. So that's the final answer. I now know what DE equals. So I think a lot of these other ones are going to kind of be similar to this. Let's just take a look maybe at one more. Actually I'm going to do this. I'm going to have you guys try these at home. Then I'm going to see who actually is watching these notes and who actually follow directions. But I would like you to try these last two pieces here. Bring it in tomorrow and let's just see what you get. And I'll do these at the beginning of class. Maybe throw them up there as a warm-up and see if you guys can wrap that up. All right. Look forward to seeing you tomorrow. See you.